So today what I want to do is really jump into working in the conceptual design environment within Revit. So what we're going to be doing today is essentially building this space frame structure, and we're going to learn how to use parametric profiles as well as looking into adaptive components and also how they relate to the curtain panel pattern-based families that are within Revit. So all these methods that we go over today is really a process of how you put things together in this environment in order to get very tectonic structures and things that, for instance, we don't have to really model this whole entire component that you see up there. It's really just talking about how we model the individual part and the individual piece that makes up that grid. And so once we understand how to make up that piece, we can actually repeat this over a facade or this particular canopy structure or any other surface that we want to apply it to, as long as we've got our component working. You should have seen, hopefully on the class website, I've started to add obviously our classes. So this is what the class page will start to look like. Obviously a little description like I talked about last class, and then if you click on the thumbnail image, it'll take you to the embedded video. That's essentially everything that I'm saying here in class and what's on my screen. And then whatever files that we were using in that class will usually be off to the right. So obviously last class was just a PDF syllabus. And then I always post at the very end of this little scroll bar here what our assignment was, or what the assignment was for that day. So you don't always have to worry about at the end of the class, writing down everything I say. You can usually wait for this posting and then refer to what's due for the class. Also, when you upload your files, you should have received some kind of email that came back to you that said, hey, you uploaded a file and it's located at this particular web address. If you didn't get that, you might want to check your spam or junk email folder, because this is generated from the website. It might get caught up in that. But that's, once you get that little receipt, that ensures, or should ensure, that your file was actually uploaded to the server, and I will actually get the assignment. If you ever want to check to make sure that your assignment got to me, in this same page, the File Upload Center, there's a little link up here at the top right. It's called Class File Directory. And when you click on that, it's basically everyone's folder. And I'll just pick, first one here. This is all the subjects, all the different assignments that we'll probably have, or at least there's a folder for it. And then if you double click into that folder, you should see that file that you uploaded. So if you ever want to double check to make sure I got it, or that you also uploaded the right file, you might want to go there. What's nice about this so far is that throughout the semester, I don't delete anything off of this. So for those of you that do lose your work from time to time, you could actually come back to here and right-click on the file and download it, so you can always get your file back. One thing to note, if you upload a file and it has a particular name or whatever for that file, and you decide later on that that wasn't the right file, you should have uploaded a later version, it has to have a unique name, so you need to rename your file. I made it so that you can't just overwrite previous files, because this way I have a kind of a track record of what was uploaded first, and you can't go back 24 hours later and give me a final component. You can just you'd have to put like version 2 or version 3 or whatever after it. So just keep that in mind when you're uploading, that it's kind of one file at a time, and it has to be a unique name. That is real important, especially when we get more involved in the semester. So go ahead and close out of that. Did anybody watch the video at all? Was the quality all right and the sound came through and all that? Because I was having some microphone problems at the beginning of last class, so I just want to make sure that worked out okay. All right, so everyone should have Revit open, and if you don't, please get logged in and open up Revit. I'm going to close out of this file. I also need to shrink my screen for some reason. Kind of cut off at the top always. So anyway, when you open up Revit, like we went over last class, you should have this splash screen that pops up. And what we're going to do today is really just work within the family section of Revit. The first thing we're going to do is open up where it says New Conceptual Mass. So if you just left click on that, and then it'll bring up this dialog box, go ahead and click on Mass, and then Open. That's going to bring us into basically the conceptual design environment is what Revit kind of refers us to. The conceptual design environment is actually made up of 3 family types. It's the one that we just opened, which is called just the massing template. There's another one called generic model adaptive, and we'll be getting into that today. And then the other one is curtain panel pattern-based family. So I'm going to be referring to those 3 as we go through the class, so you'll just have to kind of get used to which one is which as we kind of switch back and forth through the files. In this one, let's just go ahead and in your project browser, remember I always drag my project browser off to the right. If you want to kind of match what I'm doing on my screen, you can go ahead and do that. But under floor plans, where it says level 1, I want to double left click in that, and we're going to actually be in the floor plan view. What we're going to do today is essentially I just want to make a parametric pipe. And the way that Revit works most of the time is anything that is 3D is usually starts out as some kind of extruded profile. So essentially, if you can think of anything that you want to eventually extrude along a path and think about it in section, if you were to cut a section through it, what would that outline or that profile look like? And in this case, since we're just doing a pipe, this should be fairly simple. It's just going to be a circle. But up here at the very top, if you look at Create as your menu heading, this is where you've got all your kind of draw commands. And these draw commands are really just operate exactly like AutoCAD or any other CAD program that you've been in. And I think everybody here had said they had some kind of CAD experience. The trick here is there is no real true shortcuts in Revit where you can type in like you're probably used to in AutoCAD. You will notice that from time to time, if you hover over a tool, essentially you'll get this drop-down kind of blow-up dialog box that shows you. It'll tell you like what that tool does, and it might give you a little video or some example pictures, not the greatest pictures. But if you look next to where it says what this tool is, it says, for instance, in this case, place a component, and in parentheses it has a CM. That is the keyboard shortcut. So if you are used to using shortcuts, if you actually type in CM on your keyboard, it would actually take you to this command. So for those of you that like that, you can go ahead and kind of get used to looking at those. But for now, we're just going to click on circle. So you should be able to find the circle up here. It's the one at the top right of this draw dialog box. And I'm going to go ahead and left click. I'm going to make sure I snap. And just like in AutoCAD, you get that intersection snap where you've got a little purple X. I want to left click there, and that's at the origin. And I'm just going to draw a circle. It doesn't matter what the radius is. I'm just going to draw it out and then left click again. Now, anytime you want to cancel a command, essentially we're kind of still in this in a sense. You can always hit this modify, the cursor key up in the top left, and that would kind of cancel you out and start up with the next command or whatever you want to do. Or you could always hit escape on the keyboard. Now, what we're going to do here is if you just go back and select that circle that you drew, you'll notice that there's this blue dimension. In Revit, every time we draw, you're going to start to notice these blue dimensions pop up. And they only pop up when you select an item. So when I go back and select the circle, it's there. And when I deselect it, it goes away. Those are called temporary dimensions. And in Revit, anytime you see those pop up, you can actually click on the text. And I could type in a different dimension like 25 feet. And that's going to change my object. So the way that Revit works a lot of times is you draw first, you just kind of put something down first, and then you can edit what its size is, or if you want to be more specific, you could type in the actual dimensions as you're going. For now, though, what I want to do is actually make this parametric. In a sense, this is already parametric because when I click on that dimension and change the number, it's changing that shape to the next dimension. So already inherent within Revit, every object has some kind of parametric capability to it. But to make this something that I can utilize instead of always having to manually type in things, what we can do is click on that circle again, and underneath that dimension, you notice there's this little icon that looks like a dimension icon. If you left click on that and then left click somewhere off into space, that turns that temporary dimension into a permanent one. So now we have a actual dimension that's written here in this particular file, and we can start to do things when we have permanent dimensions. Everyone get that to work so far? All right, so what we can do with this dimension is we can eventually assign it a parameter. And to kind of introduce what parameters are, you probably were were involved with this in Grasshopper. But a parameter is essentially, if you can think about it, it's just a container. It's some kind of jar that you put some information in, and then that information is going to inform what happens to some kind of geometry. So a parameter, it could be anything, and I'll show you what they can be. If you click on kind of at the top left here at the bottom, there's this command here that is called family types. It's kind of this icon that has the blue, kind of blue foursquare up there at the top left. We click on that, it'll bring us into this dialog box. This dialog box pertains to any family template that we might be in, and this is exactly where we start to program and list our different containers of information or our parameters. Right now there's nothing really in there. It comes with a default elevation. We can ignore that. But what we can do here is off to the right where it says parameters, you can click the button that says add. Click on that and you will see here that you get this other dialog box that pops up, and this is real common in Revit. You're going to always have multiple dialog boxes. But down here in the middle, it says type of parameter, and if you click on that and let that menu kind of expand, this is showing you what a parameter can be. So you can see all the different headings. A parameter, any kind of container of information that you want to store in Revit, could just be plain text, can be an integer, number, length, area. You can kind of read along, all the way down to things like yes, no toggles. It could be a material, could even change a family type to another family type if we wanted to. And then you can see there's a divided surface and repeated component type. So these are all things that we can kind of store information in. We can't add more to this list. We have to work within what Revit is giving you here. In Grasshopper, that's kind of like those plugs that you pull in. That would be your integer plug and your text plug, number, and so on. So for now, we're going to make a very simple parameter here. And to do this, let me zoom in again. That looks a little bit better. We can name a parameter. And so the parameter is when you name one, it can be any name that you want it to be. For right now, I'm just going to type in radius, because I'm going to eventually make this a radius parameter. One thing to keep in mind that when we start to get into more and more parameters, and we will, some family types could eventually have 20 different parameters that we might be using at some time. As you name a parameter, each parameter has to have a unique name, kind of like our files. So you can't ever have another parameter that is a radius as well. If you wanted another radius within your in your file, you would want to call this something like radius A or radius B, or give it another name. You can have a space, so it could be radius A like that. I could also do an underscore and an A. Whatever you want to do, you can name, and these parameters can be, I think, as long as you want them to be. You don't really want a very long name, but usually when you name a parameter, you want it to be something that describes what it does. This is going to be a radius. You don't want to call it, something that's completely arbitrary, because after a while, it's going to get hard for you to kind of keep up with what does what. A lot of people will say that this is just, parameter A, and then the next one's parameter B, and you got to start to remember which one is which. So just be obvious. The other thing I'll just comment on as we name parameters: never use the hyphen. So if I wanted to call this radius A or radius hyphen A, kind of like you do sometimes, with your file naming. Within Revit, we'll get into a little bit later, we can do computational formulas that are assigned to all of our parameters. And when we start to mix things like a hyphen, Revit starts to read that as a subtraction sign and a mathematical equation. And what would happen here is it would start thinking that you're trying to find a radius parameter minus an A parameter. And you'll get some kind of error message because probably those don't exist. So just keep that in mind. Stay away from any kind of mathematical symbols as you name these parameters. There's going to be a lot of explanation here kind of at the beginning, so just bear with me. The other thing here is we'll keep all the other information here where it says length, and then where it says group parameter under, there's a whole list of categories. I'm not going to really worry about that right now, but essentially what that does is it just adds another, you see those blue lines that are in your dialog box behind this? It just gives you a heading where it starts to group parameter names, and we'll start to see that later. I'm just going to keep it on dimensions, and then we'll keep this as a, there's two different ways, there's a couple different ways a parameter can exist. It could be a type parameter, and it could be an instance parameter. For now, I'm just going to talk about how we're going to make this into an instance parameter. Let's just click on that little radio button that's next to it, and we'll make that an instance. And I'll get into what the difference between a type and instance as we move along. I'm going to go ahead and click OK, and then OK again. And you'll notice that before I click the second OK, it made that radius parameter listed under dimensions. So you can see that heading. That was that group parameter under task right there. So now that we've set that that particular parameter, if we go back to this family types dialog box, I can give this a dimension under where it says value. So maybe I'll indicate this as 4 feet for right now. So I'll type in 4 feet. And everyone knows the feet and inches symbols. If you don't, apostrophe is your feet symbol, and then quotation marks is your inches. So if you wanted this to be 4 inches, you'd obviously do 4 quotation marks. That'd make it inches. I think that's kind of universal, but I always have to make sure to cover that. So anyway, once we change that particular dimension, you'll notice that nothing here happened. The circle is still at, in my case, 50 feet. That's because we haven't assigned this dimension to actually equal that parameter. And the way we do that, and you'll notice that when I zoom in, my lines aren't very bold, but you might zoom in and you've got something that looks like this. Up at the very top here, this is called your quick access toolbar at the very top. You'll see kind of the third one from the right, there's this command called thin lines. That'll make everything one line weight. It makes it a lot easier as you start zooming in and out on very detailed things. So now we're going to select this dimension, and up at the options bar is this green, you see this green, kind of the light green bar that's in between your tool ribbon and the rest of your screen. Anytime I refer to the options bar, that's what I'm talking about, because anytime you select a different command, let me see. Try to select a different command. There we go. I've got different things that start to show up in the options bar. Sometimes a command might have many options that go along this top screen. Some might only have like one little toggle, or they might not have any. So anyway, that's where you'll find other basically options for your tool that you're working in. So back to what I was doing, I'm going to select that dimension, and in the options toolbar, there's this section here called label. If I click on that down arrow, I can now see the particular parameter called radius, and if I select it, that makes my radius and my circle change. So now my dimension reads radius equals 4 feet, and my circle has also changed with it. So now let's take, basically what we're going to be using today is going to be 2 different sizes for this circle, so that we give our space frame a little bit of scale to it, so we have kind of thicker members and intermediate members, or smaller members. And what I'm going to do here is, in another program, if you wanted a profile to be a 6-inch diameter, I would draw it, and then I'd have to hit save and save that file as 6-inch diameter. And then if I wanted another one to be a 3-inch diameter, I'd have to then do a save as of that file, type in 3 inches, and then have all these separate files. That's how you'd have to do it in any other program if you wanted all these other multiple different components that you want to use. But we can actually store all of that information in this one file. And the way that we do that is we go back to our family types dialog box, and up at the top where it says new, or it says family types and then new, we can click on that, and basically we can give it a name. Whenever we name a family type, we want to name it something that describes what it's going to be. And in this case, this is going to be pretty simple. I'm going to call this 6-inch diameter. Now I'm going to click OK. Now all that did is you'll see up here at the top where it says name, and there's this little pull-down menu. It added a heading there called 6-inch diameter, but it didn't change anything down here. All we're doing is basically naming this family type. So what I want to do is then also type in where it says radius, I want to type in 6 inches because that's what this particular family type needs to be. And then down at the bottom, I'm going to click the button here called apply. And that basically stores that information for the 6-inch diameter is now stores that parameter value at that particular dimension. Now I'm going to do that again. And this time I'm going to call it 3-inch diameter. And once I do that, I'm going to also change my radius to 3 inches. You know what? I'm doing that completely wrong. That should be 1.5 inches because that's a radius, and we're calling this a 3-inch diameter, so I'll have to go back and fix that. So anyway, I'm going to type in 1.5 inches for my radius, and I'm going to hit apply. And I need to go back to my 6-inch, and to do that, we look here at the top. I can now select and toggle between the 3-inch diameter and the 6-inch. So if I go back to the 6-inch, I need to change that radius to 3 inches so that it's really a 6-inch diameter and not like a foot. And I want to hit apply when I do that. Now if you did that correctly, and I'm going to make this box a little bit smaller, and zoom in on this circle. When we make parameters, we always want to test them out to make sure that they're doing what we want them to do before we start doing anything else. So right now, I'm going to select 6-inch diameter, and I'm going to hit apply. Nothing happens because that's probably what's already there. I'm going to do 3-inch diameter and hit apply, and you should see my circle get smaller. And then if I go back to 6-inch and hit apply, it gets bigger. We can store as many different values and dimensions that we want in this file. You could have 200 different sizes for this circle if you want, but obviously we don't need to do that. I just need these two. So what I'm going to do is click OK. Did everyone get that to work? All right. And now I'm going to go here and up to the Applications menu, which is the top left, and I'm going to do a Save As. And I want to save this somewhere. You want to save it on your computer somewhere that you can access it. And I'm going to call this profile underscore, let's just call it circle. You can name it whatever you want, but what I like to do is name it, for this class anyway, what exactly it is we made, and then, you know, so it's a profile that we're going to be using, and it's a circle. So just kind of self-explanatory there. So after you do that, you want to hit Save, and then you're going to keep this open. So this screen is just going to stay open like this, and we're going to now open up a new particular adaptive component and then start to see how we can apply this particular circle to it. So in Revit, this is a very common task that we're going to be doing throughout the class, so I want to make sure you guys can master it, hopefully today, is the way that we work is, since we're making all these different family types and we're going to be loading them into other file types, what we do is we keep that screen open and we open up a new one, and then eventually we can load into project all these, you know, other things to start to embed them together. To do that, I'm going to go up here to where it says View. So View in your kind of menu heading. And then over to the right where it says User Interface, I'm going to click on that down arrow, and before I do the next command, I want to mention something about this. If for some reason you ever lose, which I'm going to do right now, your project browser, or you lose your properties bar because you accidentally clicked on something and you want them to come back, you go to User Interface and you'll see these check boxes. I can check on the project browser and then also the properties, so I can get all that back. You know, it should come back where it was. So anyway, that might happen from time to time. Another thing that happens from time to time that I just want to get out of the way is, you see this little button up here? It's hard to see. It's kind of like this up arrow. If I keep selecting that, look at my icons. They collapse into different ways of displaying your icon. So if you happen to open up Revit or for some reason you hit that button and you notice your Revit looks a lot different than you've ever seen it before, and people start freaking out when that happens, most likely it's because of that button, and you just need to cycle through until you get to the way that you like to work, which is pretty much this tool ribbon method that we're going to be using throughout the class. So back to the user interface, I'm going to click on where it says recent files, and that will bring us back to our splash screen, but we still have that other file open in the background. And the way that you know that is when you go back to the top here where the quick access toolbar, the very last icon there, or second to last, is one called switch windows. And when I left click on that, I can see the name of my family, the profile circle, and then a couple of views that are part of it. If I were to click on one of those, it'll take me back into that file, into that view. And now I can go back to recent files by going back to switch windows. That switch windows command, we're going to be doing that a lot. So we just need to, and you will do that a lot as you work in Revit. So now I'm going to go back to here where it says families, and this time we're going to click on the new button. And we want to scroll down on this dialog box until we find the generic model templates. So all of these .rft files, those are template files. And I'm going to pick the one here called generic model adaptive. That is the only one that really works within the conceptual design environment, and it has some very powerful ways of working. So I'm going to hit, again, generic model adaptive, and I'm going to click open. And we should get this little, kind of this 3D screen again. Before we move on, I'm going to do a save as of this file. So go ahead and go back to your applications menu, save as family. And I'm going to call this one adaptive component underscore pipe. You can name it whatever you want, but essentially we're making a pipe, so I want it to resemble that. We can actually just draw here in this 3D view. One thing that's nice about the conceptual design environment is there is one additional tool here that you won't find in any other template. And at the very end of your draw tool under create, there's a point element. So there's this point that's sitting there that we can use as a reference point, and we'll get into that a little bit more. But we actually have these points that we can place in the Revit file that you don't have that ability in any other template file. So right now I'm going to click on the point, and I'm just going to place 2 points, and it doesn't matter where they are, just place them on the screen. When you select the point, you get these coordinate crosshairs, kind of probably if you're used to working in 3D Studio Max or Maya, you'll see these a lot. But basically you can drag, if you pick the blue, that drags it in the X, Y, Z, the Z, the green is in the Y, and the red is in the X. So if you want to move your components around, you can do that. I'm going to just kind of move them a little bit closer together. And again, it doesn't matter where they exist on your screen. They can be anywhere. What I'm going to do, though, is I'm going to select both of these. And just like in a lot of programs, if you window from left to right around objects, anything that is contained within that window gets selected. And if you window from, and I'm just doing that by holding in the left mouse button, if you window from right to left, anything that box crosses, it will select. So that's kind of a common, I think, selection tool for most programs. But I'm just going to window around those 2 points. And at the very top, kind of almost in the middle, there's this command here called make adaptive. So you won't get that command until you select those 2 points. Another way that you can select them is you can select them one by one, hold in the control key, select the other one. Now you see that command up there where it says make adaptive. Go ahead and select that. And now you've got these 2 points that are basically have different planes that go through it. These are called reference planes that are associated with the points, and you have a number. One says 1, the other one says 2. We'll talk about those later. But Again, what I want to do is select those 2 points. And there's a command up here at the very top left under the draw command that's called spline through points. It's actually the bottom left icon there. Just go ahead and select that, and it will draw a line that connects both of those points. Now when I pick one of these points and move them around, because I used the spline through points command, that line is always going to be connected to that point, and it'll never be disconnected. So that's nice. That's a good way to ensure that you definitely snap to those points. You could have just drawn a line and snapped to each of the points and it would have done the same thing, but sometimes if you don't snap correctly, you end up with a point that's not associated with the line anymore, and it causes some problems. Next thing I'm going to do is I'm going to left click on this black line. This is called a model line. But when I left click on it, if I look to the left in my properties dialog box, there is this command here called is reference line, and there's a little toggle button. I can change my line to be a model line, or if I check that button, I can turn it into a reference line. We want to turn it into a reference line, and what that does, you can kind of see here highlighted, is it basically gives you reference planes that are associated with that line. So eventually one day you can host things to those reference planes, and wherever that reference line goes, that hosted element is going to follow it in some degree or fashion as we program. If it was just a model line, it's just a line, and that's about it. So we've got that, and you know that you have a reference line. It's hard to see on the screen, but it is a green line instead of a black line. Now the next thing I want to do is I'm actually going to use the point command again, and I'm going to now place 2 points, but be careful and watch what I'm doing. I'm going to hover over the reference line, and see how when it turns blue, I'm going to left click. I'm going to do that 2 times on that line. If your dot shows up, or your point, look at the relative scale here. If your point is small, it has been hosted to this reference line, meaning this point is forever on this line. If it's big like that, it's this free floating point, and it's not associated with any line. So just make sure you've got that correct. And you'll know that if you were to take one of your endpoints and move your line around, or move the point around, all of those points should be moving wherever that line goes. Now I'm going to select those 2 points, so I windowed around them, and there is this option here under your properties that says show reference planes, and right now it's set to when selected. If you click in the white space off to the right, it has a pull down menu of different options. This is very common in Revit, that when you see one of these dialog boxes, occasionally if you click, you can sometimes enter in a value. Other times when you click into it, it gives you a pop-up little pull-down menu where you have other options. So one thing you have to get used to is sometimes there's things hidden within these little parameters that are assigned to the left here. I'm going to change this to set to always, and then I'm going to move my cursor off into the right of the screen, basically back into the model view, and what that does is it activates that command. So nothing's going to happen while you're in the properties dialog box, but what's going to happen is once you move your cursor into the model space, it activates whatever you did for that input. Okay, so what that does is it gives us 2 planes that are now perpendicular to this line that I can now eventually host something to. If you're familiar with Rhino and the sweep command, or in SketchUp, the follow me command, anytime you want to extrude something along a path, you have to make your profile completely perpendicular, or typically you're supposed to, perpendicular to the cross section of that line. And then you can pick basically the line as your path, and then you can pick the other profile, and it makes that extrusion, follow wherever that path goes. Essentially what these planes are doing is making it so that no matter where this line goes, I will know that I have a perpendicular plane basically to that line. So it's kind of a nice feature. What I'm going to do now is I'm going to go back to my switch windows command at the top. And I'm going to switch back into our profile circle that we just made. And we now have this option here called load into project. If you click that, it loads it into the project, and you can see here it's trying to place the circle. It should be on your screen. And if you don't see that, I'm going to cancel out of that. Basically what we've done is we loaded a circle into this new file. This circle is considered a component because it's another family that we're bringing into this family. So if you want, you could go to create, and there's this little icon here, or bigger icon, called component. And if I pick that, I can now place a circle. So sort of see that? All right. But what I would like to do is host this circle to these particular planes. So to do that, what I'm going to do is I'm going to click on create, I'm going to click on component, and before I place this anywhere, look in the options toolbar. There's a section here called placement plane, and you can click on it, and on the down arrow there's level, pick, placement point, and so on, and there's a couple different options. You will only get that once you hit create component and you're selecting your circle that you're going to place. If you don't have a circle there, you haven't loaded in your circle into this project. Does everyone have their circle component? Because it's very important. You don't? So what you want to do is make sure you go to switch windows and you switch back into that profile circle and click this button here called load into project. And for you, you can go ahead and click the top option there where it says overwrite, and there you go. So now go back into this view, click on create and component. Off to the right a little bit more, right there. There you go. All right, so now you should have in the options bar where it says placement plane, we can choose this pull down menu, and I'm going to choose the option here called pick. When I choose pick, it wants me to pick a plane. So now I can pick that plane that's associated with the point. So I'll left click on it, and then my next click, I'm going to snap to the center of that plane. So you should be able to see the crosshairs there, and I'm going to left click. That's all I'm going to do. So I'm going to do that same set of steps, but I need to repeat it again. I'm going to go back to create component, and I'm going to do placement plane pick, and I'm going to pick the other point, and then again snap to the center there. Now that we've done that, if we move our points around again, you should see that our circles follow wherever basically those planes exist. Everyone get that to work?
My circle's 90 degrees.
Your circle is 90 degrees. Okay.
To the plane.
So when you're picking these planes to place, you want to make sure, you'll notice that when I hover over that point, if I hover over the center, I start seeing the, essentially the horizontal and the vertical axis of that plane. You see how that gets highlighted? If I were to select one of those end up 90 degrees because I'm actually selecting a different plane through that point. So what you want to do is always make sure that you're kind of hovering over the corner of that so that you actually see the outline of the plane, and then it will be exactly, the way that we want it to be. All right, so what we're going to do now is I'm going to click on both of those circles. I'm just going to left click on them and select both. Once I do that, I get this option up here that says create form. I can just click on that, and it basically makes a loft or an extrusion between those two families or those profiles. So now I can move that around. Yep, so undo, undo. Undo, by the way, is Control Z. And you also have these undo buttons up here, undo and redo. you can select each, I'm holding in the control key, each of the circles, and once you do that, you get this button up here that says Create Form. Just click on that. That will be a very common, yes? So what you want to do, you probably did not hold in the control key when you selected the other profile. So you want to make sure that both are selected when you hit Control or Create Form. So try that again. That work? Not yet. Anyone else have any issues with that?
Mine is still the 90 degrees, and I couldn't get it to snap the plane. Every single time I did it, it would keep repeating the same action.
So now that we have this pipe, essentially this pipe now should be whatever the radius that was programmed within that particular family type. I want this pipe to eventually be two different radii. So, sometimes I want it to be that, or the 3-inch diameter and the 6-inch diameter. So what we can do here is, if I were to tab over, this is something else that we're going to do a lot in class. When we're trying to select things, if there's multiple things that are around, if we hit the tab key, don't hold it in, but just tap it, it cycles through possible selections. So you kind of see what's happening there on my screen. What I want to do is, and if you also notice to the bottom left of your screen, as I'm tapping, it tells you different things about what you're kind of hovering over. For instance, my bottom left corner says Mass Profile Circle, 6-inch diameter. Or if I tab over again, it says Form Element Surface. Obviously, you might have different things. But by looking at that text, and that text is down here at the bottom left, that kind of informs you a little bit about what's happening on the screen from time to time. What I want to do is tab over until I find where it says Mass Profile Circle 6-inch diameter line, and left click on it. Everyone get that to work? You should know that you've selected it because off to the top left it says Profile Circle 6-inch diameter, and then it has a radius here and a particular dimension here. Now I just did something that isn't really going to make a whole lot of sense here, because we got 3-inch diameter and the 6-inch, but we made our radius parameter an instance parameter back in the other file, didn't we? Hold on a second. Yep. Let's go back into, well, this is fine. We can modify this. Actually, we didn't really have to do these other two steps that I did earlier. It's something that we can do in the future, but to keep this simple and so we don't get confused, let's go back into your profile, or the circle profile. So if you can, the way I did that is I just went back to switch windows and went to my profile circle. And I'm going to go back here to family types, and go ahead and hit under family types, you can hit delete and delete. And basically we're deleting the heading where it said 3 inches and 6 inches, because we made this an instance parameter, and I'll try to explain this more as we go. The instance parameter can be whatever dimension we want as we place it in another file. So by telling it that it was a 6-inch diameter or a 3-inch doesn't make any sense, because essentially we could make it any dimension we want. So I could actually just click on where it says family types and new. I'm just going to call this pipe instead, because it's going to be any kind of pipe that we want it to be. I'm going to click OK. And I'm going to load into project, and you'll get this dialog box here where it says overwrite the existing version, or overwrite the existing version and its parameter values. I'm going to click on the bottom one, and then I'm going to tab over the ends here until I can select that profile circle. And over here where it says properties, if I click on that, I can choose that pipe option that we just created. So click on that little picture or the top bar that's part of the properties dialog box. Click on that and it'll give you a drop down menu and change that to pipe and activate it. Do that for the same thing on the other side, and I'll walk around here in a minute, make sure everyone's got this. And I'm going to choose pipe. Everyone see what I did there? Anyone not? All right. All right, so the reason I wanted to do that is now when you tab over that circle, again, we want to select it, just like we did. I want my profile. I thought I changed that to a pipe. So we want to make sure it says the pipe. Let me make sure my other side did the same thing. Yes. Okay, so what I want to do now is I'm going to tab over, I'm going to select that pipe, and down here where it says radius, and it's set to 3 inches, there's a little button off to the right. What we're going to do is actually make a parameter within this file that controls the size of the pipe instead of that other file. I kind of got ahead of myself there. If you click on that button, it brings you to this dialog box where we can add a parameter. I'm going to click Add Parameter at the bottom, and let's call this, we'll call this Radius as well. And in this case, we will keep it as a type parameter, and we'll just click OK. Now what I want to do is go to the other side, and I'm going to tab over till I find that pipe. And that one has a Radius button as well. I'm now going to click that button, and since we've already made this parameter, I'm going to click on it where it says radius. I'm going to click OK. Basically what happens is that radius dimension grays out, doesn't allow you to select it anymore, because now what we've done is over here in the Family Types dialog box, we've added the information here, and I'm going to move this over to the left here. And this is where I wanted to make, where I say Family Types, I'm going to click on New. And this is where I wanted my 6-inch diameter and hit apply. Keep my radius at 3 inches, and then I'm going to do the new family type again, and I'm going to call this 3-inch diameter. And this time I'm going to change the radius to 1.5 inches and hit apply. And when I do that, my whole entire pipe changes, in dimension. That's what I wanted to do. I got a little ahead of myself there. So anyway, let's go ahead and hit save. And now the last step in this file is to basically make our endpoints align to the endpoints of where this number 1 and number 2 point occur. To do that, if I click on this point that's at the end of this solid extrusion, I'm going to slow down here for a second and zoom in. There is, once you select the point, there is under properties this command here called normalized curve parameter. I'm throwing a lot of vocabulary out here today, but it's just something we're going to hear over and over again. Essentially, you should see some kind of decimal value that's associated with that. If you don't see this, you haven't selected the point that was at the end of your, basically your pipe. So you want to zoom in on it and select it. It doesn't matter which point you've selected. Essentially, this normalized curve parameter, if I were to change that value, for instance, mine says 0.16 whatever, I'm going to change it to 0.1 and activate it, and look what happens. You should see that your point travels down the basically the line. If you were closer to 1 or closer to 0.9, you might just change it to 0.8, just so you can see it move. A normalized curve parameter is basically kind of like a percentage of where that point exists along the entire length of that line. So I've actually made my point 10% away from that point. So what that means is this normalized curve parameter can only be a number, a decimal value between 0 and 1. 0, when I type in 0, is going to take me all the way to the end of the line. If I go and select my other point, or the plane of that point, this one is closer to 1. So if I were to change that to 1, it's going to drag it all the way to the end of the point. I can't ever be 1.1 or 1.5. It'll probably give you an error message. Everyone kind of understand that? We can get into more of that much later, but that's basically all you need to know for now is to get to the end point, make one 0, and the other one is 1. And now let's hit save on that one as well. And that's all we need to do for that particular family. And the way that adaptive components work is essentially we have just made a pipe that we can now draw with. So we can like draw this pipe infinite number of times on our screen, and it's basically like drawing a line, but we're actually drawing this model component instead. So you never have to do this extrusion ever again as long as you save this file. And that's one thing I want to talk to you about is you want to make sure you bring these files with you for each class, because there might be times where we go back to an earlier file and bring it in to use it so we don't have to do these steps again. So you want to keep your parts in some kind of folder somewhere that you have access to. So I'm going to keep this open. We can go back to switch windows, and where it says profile circle, let's go ahead and close out of that file. So you can go back to applications menu and just hit close. And we probably should save it. We just want to get that one out of the background because now we're going to be utilizing this particular component. Seems like a lot of work just to make a pipe, but by doing this, and probably by the end of class, we'll have that space frame exactly completed. And you won't have to, it'll just be a pretty quick, efficient way of actually putting this together. So what I'm going to do now is we're going to go back to View, User Interface, our recent files. And this time we're going to open up a new family. So I'm going to click on New, but I'm going to choose the other component of the conceptual design environment here called Curtain Panel Pattern Based. So go to View, User Interface, click on it, and then go to Recent Files. And then go to Families, New, and select Curtain Panel Pattern Based as our template. And I'm going to click Open. So this one kind of makes sense why they call it what it is that it has a underlying pattern that's associated with it. There's some adaptive points. They're kind of on a grid. We can move these points. I'm going to take this point and just drag it up and down, and it drags off the grid. And this is kind of a practice I like to do, is actually move all of these off the grid. And the reason for that is whenever we're in this conceptual design environment, we might be applying our component to a curved surface. And we want to make sure that what we've snapped to and what we're doing can be taken off the grid essentially and moved into kind of these warped configurations. And as we model and we know that everything works in a warped configuration, we know it's going to work on a straight surface and or a very complex surface. So this is just a practice that I like to use so that you're not accidentally just drawing on a work plane and then you run into problems later. So keep that open, and I'm going to go back to switch windows, and we're going to go to our adaptive component, and I'm going to click Load into Project. And I'm just going to cancel out of that command once I do that. I'm going to do a save as of this, and let's call this Curtain Panel Space Frame. Got some fast typers in here. All right. Yes?
I got an error message on mine.
You have an error message. What does it say?
It says, contains a shared family of the same name.
Okay. All right, so what we're going to do here is I'm going to do a little bit of a setup so that we can make this space frame happen. I'm going to select the corner points, and it doesn't matter which corner you do, kind of the corner points across from one another. And I'm going to use the spline to hit play. Yeah. I'm going to do the spline through points command and make that line connect from one corner to the other. I'm also going to select that line that we just made, and where it says is reference line, I'm going to click on it. Then I'm going to take a point, and I'm just going to place it directly at the midpoint of that line. And you should know that you're at the midpoint because you get a little triangle that pops up when you snap to it. The other way of getting to the midpoint is using our normalized curve parameter. If I select that point, your normalized curve parameter could be set to 0.5, and it'll get directly to the center line. Now I'm going to select that point, and where it says show reference planes, I'm going to select that, change it to always. And the last thing I'm going to do, and I'll zoom in on this one as well. Where it says show normal reference plane only, I'm going to uncheck that. What that does is it gives me all the other planes that were associated with that point. It reveals them so that we're not just seeing the one that's the perpendicular component. So all I did there is once you get that middle point, go to the left here, make sure your normalized curve parameter is at 0.5. I did show reference plane set to always, and then I unchecked show normal reference plane only. That's all we need to do there. And we got one last point to make. If I go back here where it says point element, this time before I place a point, where it says placement plane, I want to choose pick. And then I'm going to kind of zoom in. Actually, that point never gets bigger. I want to pick, I'm going to have to tab over the horizontal plane of that point. You see what I'm doing there when I hit tab? That's what I want to pick with my left mouse button, and then I'm going to place that point, snapping it to the one in the middle. And you'll get this error message that says, by the way, there's identical points in the same space. That's okay. I'm going to do that a couple times just so everybody gets it. I wish these planes would get bigger as you zoom in, but they never do. It's kind of unfortunate. Again, so what I'm doing is I'm clicking on point, placement plane, selecting pick. I'm hovering over this point right here. I'm hitting tab button one time, and it should select the horizontal. I left click, then I left click again while I'm snapping to the middle of that particular point. And you know you should have done it right if you get this error message that says you have identical points in the same spot. I don't see everyone getting that error message. Anyone need me to go over that again? Good, good. All right. So we can just hit OK. Now what we can do is I'm going to select that point that we just created. And you should know that you select it because you get these orange kind of axis grab bars to actually move this point. But off to the left it says offset under properties. I'm going to click on that button, and we're going to make a parameter here called space frame depth. And I'm just going to click OK and then OK. And if I go back to family types, that space frame depth, I'm just going to give it a number. Let's say for now 4 feet. Let's do 5 feet. That should move that point offset from where we just placed it. I'm going to select that point, and then I'll come around and help who needs help. I'm going to change this to show those planes always. I'm going to hit save. Who needs me to come around? All right. So now we've got kind of the skeleton frame of what we're going to use that are, kind of working parametrically together. We can change that depth of the space frame to any number that we want later on, but because we've set it, it's now there that we can actually program it. The next step here is to go to Create and Component, and I'm going to select my 6-inch diameter pipe, and I'm just going to snap to all of the endpoints. So I'm basically going left. I'm going to snap to the other endpoint, and you should see if you hover over the point, you get a little circle around it if you're snapping to it, and it should have it should say point. You want to make sure you're snapping to the point, otherwise these don't work. Now I'm going to do this all the way around, so one by one, snapping to the points with our 6-inch diameter pipe. And if you did it right, I could select one of those points on the end, and remember how we just moved them off the grid? As I move them off the grid, your pipe should move with them. If they don't, you did not snap to the point. So all I did is I made that 6-inch pipe go all the way around, essentially, the perimeter.
I got an error message.
What's it say?
Cannot move pipe. That is 6-inch diameter.
Okay, and the last step here is to draw. We're going to draw with our 3-inch diameter pipe, but this time, and actually to make this a lot easier, I'm going to select all of these pipes that we just created, and down at the very bottom of your screen, you should see a pair of like eyeglasses. If you click on that, I'm going to click Hide Element. Basically what that does is it temporarily hides these things. From time to time when we get so much stuff on the screen, it makes it a lot easier to hide things as we move along. So this time I'm going to click on Create Component, go to a 3-inch diameter, and this time I'm going to go from each corner down to that point that we offset. So we're making, kind of like this pyramid space frame. And so all I'm doing is going from each corner down to that point. And if I go back to the eyeglasses, I can choose Reset Temporary Hide Isolate. That brings everything back. We can test this out. If you changed your frame depth to like 4 feet, all of those things that were connected to that point should move with it. Everyone get that? Or at least some instance of it? It'll take a little bit of practice, but this is a very common method of working within this environment, so we need to make sure we're snapping to the right things and getting these concepts down, because we'll be expanding upon these as we move along. So one thing about this component is that when you looked at the initial space frame that I showed you at the beginning of class, essentially what happens is we're going to divide a surface into a grid, and we apply this component to the grid, and it gets repeated over and over again. What that means is, if you can imagine this being butt up against another component along this grid, that's what's going to happen. What that also means is that because we just drew all of these pipes on all 4 sides, you're going to have a lot of overlapping pipes. So we're going to have double the amount of pipes on your screen, or however many, as we get to each of the kind of the corners. So what I'm going to do is introduce a yes/no parameter that is going to hide these pipes, and we can choose later on to show them, and I'll show how that works here right at the end of class. So I'm just going to pick, it doesn't matter which one you do, I'm going to pick this one at the bottom. Actually, if I look at my view cube, where it says top and front, I'm going to pick the one at the front. See what I'm referring to? It doesn't matter which one you pick, just pick one. And I'm going to go over here to where it says visible in the properties dialog box, and I'm going to click that button. I'm going to add a parameter, and we'll just call this show, let's just call it side A, because I don't know where it's going to end up. And we're going to make that an instance parameter. That's very important there, is to make it an instance. I'm going to also go to a pipe that's 90 degrees, so I'll go to the one on the right here. And I'm going to do the same thing. Visible, hit the button, choose show side B. Make that an instance, OK, and OK. Last step here, and then we're done with this component. Where it says family types, those two things that we just created, the show side A and B, I'm going to uncheck those boxes, and I'm going to click OK. What that will do is it'll make it so that those components don't show up until we tell it to in the next file. I'm going to hit Save. I'm going to hit View, User Interface, Recent Files, and this time let's open up a new conceptual mass. This is the last thing we're doing. Go into an elevation view like north. It doesn't matter, north. This command that we've been using called spline through points, we can actually just draw. So I'm going to draw this kind of like one of your first Rhino exercises. I'm going to draw a curve like that. It doesn't matter what yours looks like. I'll draw another one like that. Just draw two curves with the spline. Yes?
Did you open a family type file or architecture?
Yep. So if I go back, let me, I'll just close out of this. Looks like everyone got lost somewhere. So from here, we hit save. We saved this guy. I'm going to go to View. We're going to go to User Interface, Recent Files. I'm going to click on New Conceptual Mass under Family. And hit Mass and Open. So now I'm also going to go to the north elevation. And let's go to spline through points and just go ahead and create some kind of spline. And I'm going to create another one. And then if I go into a floor plan view, I'm just going to select one of those splines. I have no idea which one I'm selecting. And I'm just going to move it up some distance. Essentially all I'm doing is trying to separate my two splines. So you want to move it up once you get into like a plan view. And you want to make sure that you're in a 3D view that has the parentheses around it. So there's two different views. There's one called 3D View 1. There's another one that says 3D View with parentheses. So make sure that your splines are separated like this across some distance. If I select each of those splines and hit Create Form, I get my lofted surface. A little piece of paper. It's pretty much the same command as loft and Rhino, you know, when you get a bunch of lines together and hit loft. Everyone get a little paper form of some sort? If your form is too crazy, what we're about to do may not work, but we'll just give it a try anyway. You got paper, paper? Everyone's got paper? All right. Select the paper. Click where it says Divide Surface once you select the paper. See at the top here where it says Divide Surface? I'm going to click that.
We can't select.
Tab over until you select the whole outline of the paper. Are you hovering over the edge? Left, and then left click. There you go. It should turn blue when you select it. And now hit Divide Surface, And it's just going to put a random, it's not random, it always does a default of a 12 by 12 grid on your surface. Depending on what your form looks like, to me this is too much. You know, I want kind of nice squares, you know, on this particular divided surface. So I'm going to do in the options toolbar, it has a U grid and a V grid. I'm just going to play with those numbers a little bit and make them smaller. So I actually want that one to be smaller. There we go. So for instance, in my case, I made a U grid of 6 and a V grid of 8. You know, yours is going to be something different. I just wanted something a little more square. And I'm going to now go back into switch windows, and if we go to our curtain panel space frame that we made, it should look like this. I'm going to load that into our new family that we opened it. In my case, it says family 10. I'm going to hit that checkbox next to the one that says family and click OK. I'm going to click into 3D view. For some reason, every time you load in a project, it gives you another view that you weren't in. I don't know why. But now what we can do, and this is going to take just a second here to generate, I'm going to left click on my divided surface. Look to the left here, it says no pattern. If I hit the down arrow and scroll down under rectangle, I should find a name, curtain panel space frame, and I'm going to left click on it and activate the view. I'm going to sit there and watch the wheel spin, and down at the bottom you have a little progress bar, and it's going to move at some rate depending on how complex your component is. And this is the time in studio when you get up and you walk around and you go get your coffee, and then you come back and you have a space frame. So here's your space frame on that particular surface. Now you'll notice, and this is the last thing we'll do, I promise, that remember we made where we had some of the edges weren't showing, they were invisible, or we turned off the visibility of them through that parameter. So if you look at the end of my space frame, on one side there I've got a whole collection of basically the components that are missing that pipe. What I can do is I'm going to tab over until I can select one of those space frame components. And if I look to the left, I see my show side A and my show side B parameters. And I have no idea which one's A or B, so I'm going to pick one. And that wasn't the right one, so I'm going to go to B. And you see how that appears? I'm going to do that to all of my ends. And I could do this in multiple fashion by tabbing over, holding in the control key, and so on and so forth. So in a way, we pretty much made this guy, except for the one thing that we didn't do yet is I had little spheres at the little corners that made it look like you had some kind of connector for the pipes. And we can do that at the beginning of next class as we kind of get into the next step of what we're going to do with adaptive components. That's all I have for now. I'm going to give you a homework assignment. And what I want you guys to do is a couple things. You can either write it down now or wait till I actually type it up. Essentially, if homework assignment number 1 for every class is always this, make sure you finish what we did in class. So if sometimes things just get out of hand as we're working and you get kind of behind. I understand that happens. You just want to make sure that you go back and review the video or try to finish up, where you, kind of got lost in class and try to complete to get to as far as we got to in this class. What I'd like you to do is finish the space frame. So, for instance, I still need to turn on the rest of my pipes that are at the other end. You go ahead and complete the space frame. If you don't like the scale of it, for instance, this looks very little and spindly. I might want to make my my form, my spline a little bit smaller. Give it the appropriate scale for a 6-inch by 3-inch diameter pipes that we were using to get something a little bit better looking, kind of like what I have here. So get the scale right, kind of play around with it. And what I want you to do is upload that to me. Make sure that I want to be able to see what you were able to do. And then after class, I'll come around to those that need help. The other part of the assignment is going to be a little bit of a research project. And you don't have to spend a whole lot of time on this. But what I would like you to do is we're going to start thinking ahead for next week. Because next week we're going to get into some case studies on kinetic panels using these methods that we've used so far. I want you to research or come up with an idea for a kinetic panel. A kinetic panel is something that obviously is going to be a repeating panel across a surface. So right now we did like a space frame. But a kinetic panel is going to have some kind of component to it that moves. So what I want you to do is either research, maybe in other classes you've already researched such one, or there's something that you would like to create. I want you to sketch out or provide images of a kinetic panel that you would like to make. And I want you to tell me what will it look like, or show me what will it look like just in a sketch. It could be real rough. And how will it move? So what's going to be the moving component? For instance, on this space frame, just to be simple, I could say this is going to be a kinetic panel, and basically the depth, that depth parameter that we made, that's going to be the movable part. And so some of these panels might move, at different dimensions. But I want you to look at it. When you get into kinetic panels, a lot of times you'll see a lot of the research done involving the sun, following the path of the sun, because everyone's trying to make these sunshades that move along where the sun is and try to block what's coming into a facade or over a canopy. So you might find a lot of examples that way. Just come up with something. I want you to upload a sketch or some images, and also tell me how it's going to move or what you plan to do with it. It doesn't have to be 100% figured out. I just want an idea. See what you're thinking of how complex you want to eventually be. And that's it. I'll stay after for questions and any kind of help. So let me close out of here. Any questions on the homework assignment? Okay.